Hello, I'm Dane, and this is Dane Explains. String theory and M-theory postulate that there are extra tiny dimensions. However, we can't perceive them because they're so tiny. Why they are so small is usually explained by postulating they are shaped weird so they can be curled up on themselves, like some kind of hyperdimensional donut. Well, are they curled up like that? Or are the things just confined to a small layer in these dimensions? How did they get so small to begin with? Well, I have an idea that might explain it. Let me explain why. First off, this is the fourth video in a series. You'll probably want to watch the others if you haven't already. I've linked them in the description. Also, I did another video about a year ago about this, and it might be helpful if you'd watch that one too. But you can watch it after this one. So this idea came to me one day when I was pondering what the most likely universe is and how we got from that one to this one. And just to recap from that video on the most likely universe, I concluded that the universe probably started from one that was infinite in every way, including having an infinite number of dimensions. I came up with two possible ways that could be. Possibility number one is using symmetry breaking. However, we're going to skip that for now since it's a complex topic and deserves its own video. So stay tuned for that. The second way, which is the one I've been prepping for these last few videos, compactifies the infinite dimensions, making them invisibly tiny, leaving only the three we're familiar with. And if you're confused, you probably didn't watch the previous videos. If the size of each dimension was determined by what order it was compactified in, then this would also go a long way to explain why some string theories have so many compactified dimensions. In fact, they could be just scratching the surface if there were an infinite number. The elephant in the room here is, why would most of those dimensions be so small? What compactified them? I thought that one of the best ways to figure this out would be to figure out if there were any places in our universe where things are getting compactified from 3 dimensions down to 2. Now that would take a lot of crushing force. Well, what is the most crushing force in the universe? Well, you guessed it, black holes. And if you didn't, that's fine too. If you took the time to watch the other videos in this series, I covered event horizons in the second one. Basically, if something gets close to an event horizon, like a black hole has, it gets flatter and it moves slower, but never appears to enter the black hole, aka pass through its event horizon. In my video on event horizons, I mentioned if the universe ended in the Big Rip, the event horizon of the expanding universe, let's just call it a cosmic event horizon, would eventually meet the event horizons of black holes. This would effectively create a two-dimensional space. However, the increasing pressure of the Big Rip would make the two-dimensional universe formed between the two event horizons be constantly increasing in energy and getting a little bit hotter. Kind of like our universe running in reverse, where there's kind of a bang crunch at the end of it rather than a bang followed by cosmic inflation and a slow and steady expansion like we seem to have with our universe. So, unless you can run time backwards, that doesn't even describe the one that's going on. However, I think we're on the right track. Forget the Big Rip. Remember in my event horizon video, I also said it's acceleration that causes an event horizon to form, which means when you press the gas pedal on your car, an event horizon forms behind you billions of light years away. Well, actually not really, since one is already out there, but it does get slightly closer to you. However, also recall I said that when you're standing on Earth feeling gravity, the ground is accelerating you. That's why we feel it pushing against us here on Earth. Oddly, this doesn't make the cosmic event horizon get closer to you. It makes it steady, like you were floating in space. Sounds kind of weird, I know, but consider what would happen if the Earth wasn't there, or the ground wasn't, but the Earth's gravity well still was. You would fall, of course, and in doing so, accelerate away from the universe behind you, just like accelerating in a spaceship or a car. The cosmic event horizon will get closer to you as a result. Well, a black hole is basically like Earth with no surface. Although if the real Earth was a black hole, or the mass of the Earth anyway, it would be about the size of a grape, so pretty tiny. So let's consider what would happen if you fell into a black hole. But instead of imagining yourself with a body and limbs, imagine you're an indestructible point observer, like someone spectating in a video game. It would also help to imagine if you had another point-like partner as well. That looks like a star, just a point of light. Now if your partner fell into the black hole, but you didn't, the point of light would get redder and dimmer until it went completely dark, never actually crossing the event horizon. Now, imagine if you and your partner fell in, but your partner started falling a few seconds before you. What would you see? Well, looking at your partner, you'd see the same thing, although it would appear to happen a little more slowly. What's more interesting is what you would see behind you above the black hole. Since you're accelerating into the black hole, the cosmic event horizon out in space starts to get closer to you as you get closer to the event horizon of the black hole. The further you fell, the closer both event horizons would get to you, one from above, the other from below, like a cosmic can crusher, and you're the can. Of course, if you had a body, you would have been spaghettified long before any of these effects became apparent, which is why it helps to think about this from the perspective of a indestructible point particle. Eventually, the two event horizons would be almost touching. You'd be stuck between them, confined to a two-dimensional layer. The only things you could interact with would be other things that fell in exactly with you. So if your partner fell in slight before you, they'd be nowhere to be seen anymore. This, of course, makes a lot of assumptions about things we have yet to figure out about black holes, but it provides a mechanism to explain why many of the dimensions in string theory are so small. Or, at the very least, how particles would be confined to tiny spaces in these extra dimensions. Who knows, we could be the result of hyperdimensional aliens who are unlucky enough to fall into not one, but an infinite series of hyperdimensional black holes. Okay, yeah, I know that's wrong. That would also mean there could be other universes out there in the form of nearby hyperdimensional black holes. They would be impossible to get to, of course, so you'd never be able to visit them, although they could combine. Also, the weight and spin of hyperdimensional black holes would have effect on the physics in our universe. So, it could also be the reason why string theorists have been able to come up with so many different possible universes, most of which don't appear to be ours. We could even have some of the extra dimensions repeat if you had tiny black holes falling into larger black holes. Things get very complex, which goes way beyond the scope of this video, however. So maybe I'll do some videos exploring the different aspects of this in the future. Thank you for watching. If you like this video, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.